Okay, I'm going to let this be seen for a little bit because I want people, whoever might be watching this, to see it in that part that we just went through. Okay. And then I'm going to erase it. Okay, everybody got this down? Again, your points for this assignment are just taking notes. So if you've got really good notes, you'll get full points for your assignment on this section. Everybody done?
Almost
Okay, you want, I'll let you have a little time to write. Okay. Are we all done? Okay, we can go ahead and erase it. Okay, the next basic unit is called an angle. Okay, and I'm not going to go into the two different parts, but basically it's made up of two half lines. Okay, it's the intersection of half lines like this. So they have one common endpoint. Okay, so these are basically half of a line. And they intersect at a point that's called the vertex. Okay, so this is the half of another line. These are technically called rays, but I'm not expecting you to know that. So half of a line is really called a ray. It's just half of it going out. But an angle is made up of two rays intersecting at one endpoint called the vertex. Okay. So it's they're different lines, two different half lines connected at one point called the vertex. Okay, so that's really the definition of that. Okay. Yeah, we use angles a ton. Okay. That's something that's just used all over the place. Lines we use somewhat. We talk about lines when we're talking about distances, or when we draw pictures, we use lines, those kind of things. So lines are used a lot. Angles are used when we're talking about different shapes that we have. We can have different angles. So that's what to name these. If there's just one angle at a point, so if there's one angle at a point, example, like this, you can call it angle A, okay? You can name it, if there's only just one angle there, you can name it by its vertex. Okay, this is the vertex. So that's how you do it when there's just one angle. If there are several angles, at a point, then you have to name it differently. Okay, so this is one way, this is another way. So if I have something like this, so notice at one vertex there are several angles because I have more than two rays. Okay, so when you're doing that, the vertex always goes in the middle when we name it. And then let's say if I have A, B, D, and E. So when there's more than one angle at a point, you must use 3 points to identify your angle. So if I'm trying to identify this angle right here, between D and E, you would write it as angle DCE. So this starts at D, it goes to the vertex C, and then it goes to E. So it explains how you made the angle. Notice the vertex is always in the middle. The vertex is always in the middle. Okay. A way to do the one over here, this angle right there, you could do it as BCA, or you could do it as ACB. It doesn't matter which one you start with, just the vertex has to be in the middle. So I could name this 2 ways, angle ACB or angle BCA. The important thing is the vertex is in the middle of the name. Okay, that's just because if I name angle C, it's really hard to know what am I talking about. Which one am I talking about there? Because there's more than one. Okay, so you can use it as one if there's only one angle there. Otherwise, when there's several angles, you have to name it with all 3 letters, but the vertex is in the center. Okay, so those are the basic shapes. And then we kind of classified, remember we classified different triangles by shapes and stuff. But we didn't go into, I don't know if we did. Did we go into all polygons, the different names, or did we just do, we did, okay. So did I talk to you about different types of polygons?
Yeah.
What kinds are there? Okay, those are polygons, but this one is concave, convex, and regular. Did I talk to you about those? Yeah, I didn't think so. Okay. So concave polygons are when your figure basically, it's harder, it's easier for me to explain. Okay, a concave is where you basically see kind of a cave in it. So it caves in there. That's a concave polygon, okay? The true definition of a concave is that I put 2 points and I connect them. If it goes outside, when you connect 2 points inside the polygon, and it goes outside like that, then that is called a concave. Okay, so if 2 points in the polygon do not, 2 points in the polygon have a line drawn through them, and if it goes outside, if the line goes outside, then it's concave. lots of words to just really show you if there's some side that looks like it's caved in on itself, that's a concave polygon, okay? So I always remember it just by, oh, it looks like there's a cave here, and that tells me that there's a concave polygon. The other one is a convex polygon. And a convex polygon is something like, okay, so no matter where I put 2 points in the polygon, if I pick any 2 points in the polygon, that line between those points will always stay inside. So it doesn't matter where I pick 2 points, when I draw a line between them, they're still inside the polygon itself. So 2 points connected by a line stays within the polygon. Okay, so we normally, when we are talking about polygons, most polygons that we talk about are convex. But there are times when we use concave polygons. Okay? If something looks like that, and we have to draw it like that. A lot of concave convex is used when you're describing rocks and what rocks looks like, because angles can go in and stuff. When you look at the structure of rocks, there's a lot of concave areas versus convex areas. So that's something that they use. So when people were studying rocks, which is part of the earth, they came up with a way of describing those 2 different types. Okay? It was a convex or a concave. Then, in the convex, they're called regular polygons. It falls under just convex, okay? And a regular polygon, all sides and angles in the polygon are the same size. So when we're talking about a triangle, it's an equilateral triangle where all these are the same, and because all of them are the same, the angles are also all the same. Okay? So it's an equilateral as a regular polygon of a triangle. Okay? In a quadrilateral, it's a square. Because a square, all the sides are the same and all the angles are the same. Okay? I can't draw really a pentagon very well, but a pentagon has 5 sides, and it's when all sides are equal. The hexagon is easier, but I still am not a good drawer, I'll just tell you. We assume all these are equal, so a hexagon has 6 sides. All of these sides are equal, and therefore all the angles are actually equal. So we break, and then we went into these, the triangles, and talked about the different types of triangles. And then we went into, well, this is a square, but we went into the quadrilaterals and talked about quadrilaterals. And we talked about how they're named, okay? So they do not fit into regular, however. All triangles are not regular, all quadrilaterals are not regular, but they are all convex, okay? All quadrilaterals and all triangles are convex. that we talk about, that we name. So give me some types, Brand, give me one type of triangle that we have. One classification of triangle.
What do you mean what classification?
We've got some specific names of triangles. What are some of them?
Three-sided.
Well, that's just the definition of a triangle. Yes,
Isosceles.
isosceles is one. What is true about an isosceles triangle? What's true?
Two sides always be the same.
Yes. Two sides are equal, okay? Equilateral, I just talked about that. How many sides are equal on an equilateral?
All of them.
All of them, all three sides. Three sides are equal. Well, what would be the other one that goes along with that when no sides are equal? Somebody remember the name of that?
Say it again.
What is the name of the triangle that has no sides the same? It's one you don't hear very often. It's called a scalene.
Oh.
A scalene triangle has no sides equal. Okay. Just doing a quick review of these. Okay, that is the classification by sides. We also do triangles by angle. Okay, so this is going to be by angle. Okay, what's one of the types that we have by angle? There are three names that go along with the angle size of a triangle. What's one of them? Ezekiel, what's one of them?
One of what?
What was it?
One of what?
One of the triangle names, we classify it by the angles.
Right angle?
A right angle, that's right. A right angle, or right triangle, has a right angle in it, like that. It has one right angle. Okay? What's another kind by angle? Peyton. That's right, acute. There's an acute triangle. And that's where all angles are less than 90 degrees. Okay. Gavin, do you have the next one?
Obtuse.
Obtuse. An obtuse triangle, is one angle is greater than 90. Okay, so that's one of the other ones. So that's how we classify triangles. It's just by their side lengths and by their angle lengths. Okay, I think that warmed up a little bit. This is great. Okay, so then we started talking about quadrilaterals. We're going to quickly go through those. Okay, the most simplest was a trapezoid. What is true about a trapezoid? Anybody remember?
The rows. Trapezoid.
What's a trapezoid? Do you remember? What's true about a trapezoid? What has to be true? This is four-sided, it doesn't matter what the sides are like. Okay, what do we have to have for a trapezoid? Yeah,
One pair of parallel sides.
yes, it's one pair of parallel sides. This is a symbol for parallel. Okay, so that means parallel. Doesn't look right. Parallel, there we go. Okay, so under a trapezoid, then we have what's called a parallelogram. What is true about a parallelogram?
All sides are parallel.
Well, two pairs of parallel sides, because they're not all parallel to each other. They can't be all parallel, then you just have four lines, okay? So it's two pairs of parallel sides. Okay, so here I'll draw a picture of this one. This is an example of a trapezoid. This is an example of a parallelogram. So parallelograms fall under trapezoids because they just have one more set of pairs. And then under parallelograms, we have what are called rectangles. How is a rectangle different than a parallelogram? What does it have to have besides two sets of parallel sides? Yes.
All 90 degree.
All 90-degree angles. So this is a parallelogram with all 90-degree angles. Okay. Under rectangle, we also have a more specific category, a square. So how is it different than a rectangle? Or how is it more specific than a rectangle? A rectangle that has what?
All equal sides.
All equal sides, that's right. So it's a rectangle that has all equal sides. Okay. Now, that's one kind of avenue from rectangles or from parallelograms. There's also another branch over here, and they are called the rhombus. Does anybody remember? It's a parallelogram with what? Remember what a rhombus is?
They're two equal sides.
Actually, all four sides are equal. A rhombus has, that's a kite, I think you're looking at.
The bottom one is the
Rhombus? Okay. So the rhombus is, a square is a rhombus, by the way. So a square fits into rectangles, but a square also fits into the rhombus category because a rhombus is just a parallelogram with four equal sides. Now, a rhombus doesn't have to have 90-degree angles, so not all rhombuses are squares, but all squares are rhombuses. Okay, so that's something to think about. There's one quadrilateral that doesn't fit in any of these categories. It's called a kite. Okay, the kite is where you have two adjacent pairs of equal sides. So the adjacent sides are the same sides. So you have two pairs of adjacent, that means they're right next to each other, sides the same sides. Okay, so in that, you can have the top two are equal and then the bottom two are equal. So they're adjacent, they're not across from each other, but they're adjacent. So kite doesn't really fit into any of these. A square fits into both of these, the rectangle and the rhombus. A rhombus doesn't fit into these. And then the kite is just an oddball. It's the oddball. Because it doesn't really fit into anything, it's just a kite. So those are the different types of quadrilaterals that we have. Okay, just as a quick review on those. Okay, so that is it for this section. I would recommend that you keep this section, these notes, because you can use these notes on the test that's coming up. So you can use the notes on the test, along with any other notes you